All right, let me work through the test review. So, number one, write the equation of the square root graph shown. Okay, so a couple things. I know that this starting point, so this is basically, you could think of it like the vertex, I guess, right? Like it's the initial point that it's always at the origin, the parent function, and then it's gonna shift from the origin. So from 0, 0, it goes to the right 4. So to the right 4. So let's think about this. So I know the parent function looks like this, and to the right, it's inside lies, right? Because any horizontal left to right movement is attached inside to the x, and it's going to be opposite of what we think. So right is going to be negative 4. So x minus 4. Okay. It's also translated down 2. So outside, right, away from the x, outside of the parentheses, or the square root in this case, it's going to go down. Actually, it's down 2. So negative 2. And it's reflected downward. So this is going to be a negative outside. And just to confirm, if we plug in the values for x and y, right, because essentially this is going to be equal to y. If we plug in x and y, we should get, it should satisfy, right? So if x is 5, 5 minus 4 is 1, square root of 1 is 1. So negative 1 minus 2 is in fact negative 3. So once you think you have the equation, always plug in a known point. So here the known point was 5, negative 3. Okay, graphing. Let's, number 2, graphing. So y equals the square root of 4 times x minus 4, all minus 5. So 3 things are happening. This is going to shift to the right 4. It's going to shift down 4, down 5. And it's going to be a vertical stretch, right? It's going to stretch it vertically. Right, because if you think about this, this 4 is inside of the square root. So you could actually take out a 2. And so this is going to be stretched by a factor of 2. All right, so get a rough sketch going here. It's not going to be precise. Okay, so this is going to be to the right and down. So if we go right 4, down 5, it's going to stretch upward, roughly. We could get a known point if we wanted. So if we let x equal 5, right, because that's the number just right of 4. So if x equals 5, 5 minus 4 is 1. 1 times 4 is 4. Square root of 4 is 2. 2 minus 5 is negative 3. So at 5, this should be at negative 3. 5, negative 3. Okay. Number 3, same thing. To the right, 5 units. It's going to go up 3 units. It's going to be reflected downward because of the negative. So it's reflected downward like this. and it's going to be compressed. So it's going to be smaller. It's going to be crunched, like compressed really is the word, by a factor of 2. All right. So rough sketch. So from the origin, we're going to go right 5 and up 3. So right 5, up 3. It's reflected downward, and it's going to be a little skinnier than normal. All right, and if we pick a point just to the right of 5, so 6. So 6 minus 5 would be 1. Square root of 1 is 1. And times 1, negative 1 half, is negative 1 half plus 3. So 2.5 basically. So at 6, this is going to be 6 comma 2.5. It's always good to have that second point. Typically, the point that's right next to wherever the square root function is starting. And I guess the reason for that is because if you think about the way the parent function works, that very next point, 1, the square root of 1 is 1. So that point next to it should typically be easy to find, usually. Okay, number 4. Write the equation for the parent of the square root function after it has been reflected across the x-axis. So that means it's going to be negative, vertically stretched by a factor of 4, shifted up 15 units, and shifted to the left. So the inside is going to be positive. So this means, so negative, because it is reflected across the x-axis by a factor of 4. Square root x to the left is plus 7, and then up 15 units. Okay, so let's think about this real quick. So it's going to be it's always a rough sketch. So to the left, 7, so negative 7, up 15, and it's going to go down. Typically like that. All right, the domain for this guy is going to be all the possible x values. So this is going to be bracket negative 7 towards infinity, right? Because x's go towards infinity to the right. The range is going to start at, well, it's going to start at negative infinity and go up. Typically, I mean, visually looking at this, you're saying, okay, well, it's at 15 and it's going to go down towards negative infinity. Yeah, I agree. However, when we write this, you always want to write the smaller numbers to the left. So negative infinity is definitely the smallest it could be. And it's going to go all the way up to including 15. Brackets. Number 5. Solve the equation for x. Okay, this is an ideal situation because it's just one square root. So I'm going to isolate the square root. I'm going to move everything I possibly can to one side, and the square root is by itself. So this is going to be plus 1 to both sides. So 4 square root 3x plus 2 is equal to 16. I'm going to divide both sides by 4. On the left, we have cancels. This is going to be 4 on the right-hand side. So square root 3x plus 2 is equal to 4. All right, I want to unlock the square root. So that means we have to square both sides. So left-hand side, square root and square cancel. 3x plus 2 is equal to 4 squared, which in this case is 16. And this is just basic one variable algebra problem, right? Minus 2 minus 2, 3x is equal to 14. And divide both sides by 3. Divide both sides by 3. Left side cancels, and we have x is equal to 14 thirds. All right, number 6. This is a little less than ideal, mainly because we have double square roots. We might have to go to some scratch paper for this one. Root 5x plus 6 minus 1 is equal to root 3x plus 3. All right. So this is probably the pinnacle of these problems, and it's because the square root is on both sides with a number, right? This number. My suggestion would be to put both square roots on the same side. So that means I'm going to add 1 and subtract root 3x plus 3 from both sides. So this is going to be the square root 5x plus 6 minus square root 3x plus 3 is equal to positive 1. So a couple ideas here. The 1 is positive, which doesn't really make that much of a deal, but I'd rather deal with positive numbers. Since the square roots are on both sides, or since the square root is on one side, they're both on one side. So the next step is going to be to square this thing. Right? If I square this, this is actually going to make the square roots go away. At least one of them go away. And then we'll square it again here in a second. So when you're squaring this, you can do FOIL. There's nothing wrong with doing FOIL. But if you followed my videos, there is a little technique that I like to use. I'm going to use the fact that when I have two things being squared, this is going to come out to a squared plus 2ab plus b squared, right? This is a nifty little trick. So this is my a and this is my b. So a squared is going to be a times a, basically. So when you multiply square roots and the radicands are the same, the radical goes away and you're left with just the inside part. So 5x plus 6. All right. We'll do b squared next. B times b. So negative times negative is a positive. And then just the inside part again. Now comes this middle term here, this 2 times a times b. So it's going to be 2, negative 2. And then when you're multiplying square roots, you multiply the radicands, the inside part. So we're just going to, for the time being, that's a 6. Multiply the inside parts. I'm not going to FOIL that out just yet. All right, and this is going to be equal to 1 squared, which is 1. All right, let's combine some like terms. So this is going to be, so 5x, 3x is going to make 8x. 6 and 3 are going to make 9. Minus 2 with all that equals 1. I'm going to move everything that doesn't have the square root to the right. So this is going to be minus 8x minus 9. Minus 8x minus 9. So left-hand side, we have negative 2, square root, and I'm just not writing it because I'm lazy. And this is going to be negative 8x. And this is going to be 1 minus 9, which is negative 8. All right, I'm going to divide everything by negative 2. Notice how I'm individually dividing everything by negative 2. Because on the left side, we have cancels. If you put one big fraction bar with the negative 2, it may get confusing. So this is going to be 4x. And this is going to be a positive 4 because negative and a negative cancels. Make a positive. All right, and now we're left with square root on the left-hand side. So I'll go and write it in now. 5x plus 6, 3x plus 3. Okay, we want to get rid of the square root. So I have to square both sides. All right, left-hand side, this is ideal because the square root's going to go away and you're left with the two factors. So left-hand side, we have 5x plus 6, 3x plus 3. All right, right-hand side, 4x plus 4 squared. Again, we're going to use our trick. So a times a, that's going to be 16x squared. B times b plus 16. And then 2 times a times b. So 4 times 4 is 16, times 2 is 32. So plus 32x. All right, left-hand side, we're going to FOIL this out. So let's distribute. So this is going to be 15x squared. Outer is going to be 15x. Inner plus 18x. And then last plus 18. Again, equals, and I'm gonna rearrange these in descending order to make it easier to look at. So this is going to be 16x squared plus 32x plus 16. Okay. On the left, we can combine 15 and 18. That's going to be 33. This is 15x squared plus 33x plus 18 is equal to 16x squared plus 32x plus 16. Okay, I'm going to move everything to the right. So minus 15x squared plus, actually it's going to be minus 33x minus 18. I'm going to do this to both sides. So negative or minus 15x squared minus 33x minus 18. All right, left-hand side, this is all 0. That's nice. Right-hand side, 16 minus 15 is 1. 32 minus 33 is negative 1. And then 16 minus 18 is negative 2. Okay. We have a quadratic equal to 0. We're going to factor two numbers that make negative 2, right? If you use whatever method you like. But two numbers that multiply to make negative 2 that add up to negative 1. So we have 1 and negative 2. I feel like that's it. So negative 2 times 1 is negative 2. When you add them together, yeah, so 1 and negative 2. So positive 1, negative 2. Okay. This is saying that x plus 1 is equal to 0. X minus 2 is equal to 0. Or x is equal to negative 1. X is equal to 2. All right, we have to test these numbers back in the original problem. So way back in the beginning. So -1 and 2, basically. So -1 and 2. This is going to be, so -1. -1 is going to be -5 plus 6 is 1. 1 minus 1 is 0. Right hand side, -3 plus 3 is 0, square root of 0 is 0. All right, so -1 works. Let's try 2. So 5 times 2 is 10, plus 6 is 16, square root of 16 is 4, 4 minus 1 is 3. So we have 3 on the left. Right hand side, 3 times 2 is 6, 6 plus 3 is 9, square root of 9 is 3. Okay, so in this case, both our answers checked out. Okay, little recap. So what do we need to be successful? We have to move both square roots to the same side. So let's suppose you don't do this, right? Let's say you don't move both square roots and you just square this straight up. Well, on the right hand side, the square root will go away. On the left hand side, it's going to get worse. And then the numbers are going to get really big. So it's my recommendation that you move both square roots to one side, the constant to the other side. You're going to square both sides. Then when you get down to one square root, you're going to move everything to one side. You're going to square both sides again. Then that's going to do away with the square roots symbol, the radical. And then you're just expanding it all out, combining like terms, moving everything to one side, factoring, using, in this case, the little AC method. Quadratic formula is also a good go-to. And once you get your two answers, always check them in the original. Okay. Number 7, simplify. All right, I feel like let's go to the scratch paper. So we have fourth root of 128, x to the 15th power, y to the 10th power, and z to the 20th power. Okay, fourth root. We're going to factor 128 into its prime numbers. You could use perfect roots if you want. I like prime numbers. That's how I was taught. So if I use 2, this is going to be 6 and 4. Using 2 again, this is going to be 3 and 2. 2 will make 16. It's going to be 2 and 8. 2 and 4. 2 and 2. All right. Because this is a fourth root, we need groups of 4. So 1, 2, 3, 4. All right. So the group of 4 will come out of the square root as a single 2. So 2. Left inside of the fourth root. Actually, I should leave some room. So we know that this is going to come out as a single 2, and then there's going to be 2 times 2 is 4 times 2 is 8. So 8 left inside. 8 left inside. So 2 outside, fourth root, and then 8 inside. Okay, x to the 15th power. So we could write out 15 x's and circle every set of 4. Or if we divide 15 by 4 and just look at the whole number part. So 4 goes into 15 3 times, right? Because 4 times 3 is 12. So it goes in 3 times. So that means and x will come out with an exponent 3. And because 4 times 3 is 12, right? That means that there's going to be 3 x's left inside. So hopefully you can follow this logic, right? 15 divided by 4, the whole number is going to be 3, remainder 3, right? Because 12, remainder 3. The remainder stays inside. And then the 3, the whole number, comes out as the exponent outside of the fourth root. Okay, y to the 10th. Same idea. We're going to divide 10 by 4. So it's going to be 2. That's what comes out. And the remainder is going to be 2, right? Because there was 10. I took out 8, right? 2 sets of 4. And there's 2 left over. All right, z. This one's nice because 20 divided by 4 is a clean number. That's just 5. So 2x cubed y squared z to the 5th, and the fourth root of 8 x cubed y squared. This is the answer to number 7. Okay. Simplify. I feel like I can do this on this screen. Okay. All right, so there's a couple of different thoughts here. In this particular, so every situation is different, right? Like it's always situational. There's no one way fits all. But in this particular problem, I noticed that the exponent is negative. So I want that to be positive first. So that means I have to reciprocate the fraction. So flip it basically. So the first rewrite step, 496 over 128. And now it's going to be positive 3/4. So it was negative 3/4. Now it's positive 3/4. Okay. So here, again, fork in the road, right? We can either cube the top and bottom and then take a fourth root, or we take a fourth root first and then cube top and bottom. So let's think about it, right? You always want to think a couple moves ahead. It's like chess. If I cube 4,096, this number is going to get very large very quick. And then we're going to have to take a fourth root of that. That's less than ideal. So let's take a fourth root first and then take it and then cube it. But I guess prior to that, they're both even. So we can simplify the inside numbers because they're both even. Typically by, let's see, 8, 9. So we can use 2. Could we use 4? Yeah, we could use 4. But let's just say we didn't notice that, right? Let's just keep it simple. If this is reduced by 2, this is going to be, the bottom is going to be 64. The top is going to be, so 2 goes into 4 twice. 0, 2 goes into 9 4 times. And then 16, so 2 is going to go into 16 8 times. 2048. Okay, again, both even. So if we reduce this by 2, we're going to get 10, 24, 32. We can actually keep this going for a minute. So let's see, 512 over 16. I mean, if you can do this with bigger numbers, that is ideal. But, you know, I'm assuming that I don't see it. So this is going to be 256 and 8. And this is going to be 128 and 4. 64 and 2. And then 32 over 1, which is basically just 32. Okay, so now, so 32 to the 3/4 power. All right, this is way better already. So now, again, I want to take the fourth root as much as I can first and then cube it. Because again, if you cube this, it's going to be 32 times 32 times 32. And then we're going to have this huge, long prime factorization tree. So fourth root, this is going to be 2, 16. Now, if you have this memorized, this is going to be nice. But again, I'm assuming we don't. So 2 and 8, 2 and 4, 2 and 2. So fourth root is going to be a 2 that's coming out. And it's going to get cubed. And then left behind is a 2 to the 3/4 power. All right, 2 cubed, 2 times 2 is 4, times 2 is 8. So this is 8. And then, so 2 cubed to the fourth root of 2 cubed. So this is going to be the fourth root of 8, basically. Could you have left this as 3/4? Yeah, you could have, but I feel like this is good right here. Okay, number 9. All right, first thing is that the bases are all the same. So really, on the right-hand side, when we multiply common bases, we can add the exponents. So 3 plus x minus 1. And we can equate that to the exponent on the left, 6x minus 2. So really, I don't even care about the bases anymore, because this is just going to be 6x minus 2 is equal to 3 plus x minus 1. So 6x minus 2 is equal to 3 minus 1, which is 2 plus x. Okay, getting x by combining the x's one way and the numbers the other way. So if I add 2 to both sides, I'm going to get 6x is equal to 4 plus x. Subtracting x from both sides, I'm going to get 5x is equal to 4. So ultimately, x is equal to 4/5. So you got to be very careful with the exponent properties, right? When you multiply common bases, we add the exponents. If for some reason this was division, right? If there was a fraction here, we would have to take 3 minus x minus 1, and the negative would have to distribute. It's not the case right now, but it could very well be. Simplify. All right, so we don't like negative exponents. Here, every exponent is negative. So you could, in this case, reciprocate everything, flip everything, because everything's negative. If there were a couple of negatives here and there, like sprinkled in, and then there was some positive numbers, it could get really confusing. Switching first isn't always ideal, but in this particular case, it is, just for the simple fact that everything is negative. So this is going to be 3/5, x to the 8, y to the 6, z to the 5. All overs 3 cubed, x to the 5, y to the 2, z to the 7. Okay, as mentioned, there is division. So it's always top minus bottom. Top minus bottom, as long as the bases are the same. So this is going to be 3, 5 minus 3, because 5 minus the bottom, x, 8 minus 5, again, top minus bottom, y, 6 minus 2, z, 5 minus 7. Now notice, there's nothing in the bottom right now. Everything is in the top. So everything's going to stay in the top unless it's negative at this point, after this point. So let's see. So this is going to be 3. 5 minus 3 is 2. X, 8 minus 5 is 3. Y, 6 minus 2 is 4. Z, all right, see, here we go. 5 minus 7 is going to be negative 2. So notice, everything is up top still. Everything's in the numerator. The only thing we have to move is the Z. So 3 squared is 9. X cubed, y to the 4th, all over Z squared. Okay, number 11. All right, so we have parentheses with exponents inside the parentheses and exponents outside the parentheses. In this particular scenario, it's best to handle the exponents that are outside the parentheses and distribute them, so to speak, inside, right? Because when you have a power raised to a power, you can multiply. So this is going to be, right, I'm going to multiply these exponents. So a to the 8, b to the 10. Now notice, parentheses go away once I distribute or multiply. Times, all this is being times, right? 2 times 3, 2 times 2. So a6, b4. Okay, negative 2 and 2, negative 3 times 3. Or negative 2 times 3. So here, yeah, it's negative. I'm going to disregard that for a moment. I don't want to move it just because it's negative, right? I want to run the exponent through all the other exponents. So this is going to be a to the negative 4, b to the negative 6. Okay, everything's being multiplied, so we can add the exponents. So this is going to be a, right? I can add all the exponents. 8 plus 6 plus negative 4. 8 plus 6 plus negative 4, or minus 4. And then b, 10 plus 4 minus 6. All right, so this is going to make, so 8, 9, 10, 11, 12, 13, 14, minus 4 is 10. 8 to the 10. 10 plus 4 is 14. 14 minus 6 is 8. Okay. We're almost there. Last page. All right, simplify. Write the answer as a reduced fraction with no negative exponents. Okay. Negative exponents. So this means that it's going to put all this in the denominator. So now it's positive. Okay. Did I want to do that first? That's the question. Right? Did I want it? Because if I don't, what's my other option? If I don't write it like this first, the other option would be to do what we just did and take the negative exponent and multiply it, right? Because you can distribute, so to speak. So that would be 4. So when you multiply exponents, top times top, bottom times bottom. So this would be 10 over 5, which is basically 2. So this would be 4 to the negative 2, 5 to the negative 2. So notice here, I feel like that way is a little bit better, because if not, you're going to have to apply the fifth root to the denominator. You're still going to get 4 squared in the bottom, 5 squared in the bottom as well. But here, this is going to be like the same thing, right? 1 over 4 squared, which is 16, and then 5 squared, which is 25, right? Because these negative exponents push those bases down to the denominator. So really, the multiplication here is going to be however much 16 quarters are. So what is that? 16 quarters? Or you can just multiply. See if I can do it mentally. 10 quarters, what would that be? 250? Plus 6 quarters. So $1.25. 775? No, 375. Let's see. It's 30. 12, 15. That's a 5. Placeholder. So 5, 2. All right, so this is going to be 0, 10, carry the 1, 400. 1 over 400, right? 1 over 400. Okay. That one, I think that one is better to send the exponent through first. All right, number 13. Graph the equation below. So y is equal to negative 2 cube root x plus 2 minus 1. Okay, so let's remember what the cubed root function looks like. It looks like an S kind of thrown down or stretched out rather. It's going to look like something like that, right? Going through the origin. So this is the cube root of x. Okay. The horizontal shift is going to be to the left 2 and down 1. So left 2, down 1. Then it's going to be rotated, flipped about the y-axis. So left to right this way. Well, I mean, because of the symmetry of this thing, it really doesn't matter which way you rotate it because it's going to look the same way because of the symmetry. And then it's going to be a vertical stretch by a factor of 2. So ultimately it's going to look something like this, right? Negative 2, negative 1. And then it's kind of stretched out. Yeah, so again here, the best thing to do is to, step 1 would be to flip it, stretch it, and then shift it left and then down. That's the order that I would do it in. Otherwise, you might get slightly confused. Number 14, solving for x. All right, so we got 2 solving for x, so we can work downward here. So if I do, let's do 14 right here. Okay, so 3 minus 3 cubed root x plus 5 is equal to negative 3. Again, I want to get everything to one side and the root by itself. So I'm going to add 3. So negative 3 cubed root. So 3 minus 3 is 0. Or negative 3 plus 3 is 0. I'm going to divide both sides by negative 3. Left side we have cancels. Cubed root of x plus 5. And 0 divided by anything is 0. Okay. I need to cube both sides. So this is going to be, right, I'm cubing both sides because this is technically a 1/3 power. And 1/3 raised to the cubed power would just be 1 is going to cancel. So x plus 5 is equal to 0. Then we have minus 5 from both sides. X is equal to negative 5. We check our answer. Negative 5 will definitely work because x minus 5 is 0. Cubed root of 0 is 0. Times negative 3. Let's see. I feel like it's not going to work. I feel like there's no solution because negative 5 plus 5 is 0. Cubed root of 0 is 0. Times negative 3 is 0. So on the left-hand side, we have 3. Right-hand side, we have negative 3. So I feel like this would be no solution. Only because when we check our answer, it doesn't work out. Number 15. All right, the last problem. Okay, so again, same idea. Move everything one side and get the exponent all by itself. So this is going to be plus 5. So 3x minus 2, 2/3 is equal to whatever 7 plus 5 is, 12. Okay, divide both sides by 3. Left side cancels. So I'm going to give myself some room because I'm going to do some writing. X minus 2, 2 cubed, or 2 root 3 is equal to 4. Okay. When the exponent is a fraction, it's not so clear that, right? Because you could just do the reciprocal, 3/2 to both sides, and think, oh yeah, it's good. However, there's a little bit of analysis that has to happen. So this top number, the numerator in the exponent, is even. When it's even, this is basically like saying taking the square root, right, of both sides. That's the only way to undo it. So anytime you introduce the square root, you have to put a plus or minus. So a plus or minus is definitely going to show up. So plus or minus must show up. So what am I saying? I'm saying that when we do 1/2, right, this is like taking the square root. And when I do that, we need this plus or minus business to show up. So left-hand side cancels. So x minus 2, 1/3, right, because the 3 is still there. We could have done 3/2, but, why? And then plus or minus 4 to the 1/2 power. Basically the square root of 4, which is 2. Okay. I'm going to cube both sides. Left-hand side cancels. X minus 2 is equal to, okay, the plus or minus, because this is odd, the plus or minus can actually come out and not affect the value of this thing at all. So plus or minus, whatever 2 cubed is, 2 times 2 is 4 times 2 is 8. Okay, so we're going to get 2 answers because we have to add 2 to both sides. So x is equal to 8 plus 2, which is 10, or negative 8 plus 2, which is negative 6. We can check both of our answers. 10 minus 2 is 8. Right, 10 minus 2 is 8. Cube root of 8 is 2. 2 squared is 4. 4 times 3 is 12. 12 minus 5 is 7. So we know that 10 works. Okay, negative 6 plus negative 2 is negative 8. Cube root of negative 8 is negative 2. Negative 2 squared is 4, and we're right back to the same problem, and this works. Right, because 3 times 4 is 12. 12 minus 5 is 7. All right. So hopefully this works. Good luck.